Hi all, welcome back. And in this video, we are going to learn about how to express an expression already given into a relational algebra equation. Okay, so something like, let's say we have a relation like A, and it consists of some attribute, and another relation, let's say S, and it consists of attributes like B and all. And if we are asked in some questions like retrieve, so this is a statement that is being made. So retrieve A's values. So retrieve A's values of R that are more than, or those are more than more than some some B's of S. Okay, some B's of S means at least one B's of S. Okay, at least one B's of S. Okay, so retrieve a value of A, those are more than or greater than some B's of S. So for that, if we need to construct a relational algebra expression, so it will be like, for retrieve A's values, we will write phi A, I mean projection of A. And since we are comparing value of A and B, so we will do the cross multiplication. And after doing the cross multiplication, we need to apply a predicate condition, and we need to write that R dot A has to be greater than S dot B. Okay, so this is the situation. So it will retrieve all the A's values of R dot A, which are greater than some B value of S. Okay, so this is the way of retrieving. In other words, we can write it via conditional join. So actually this whole part we can substitute with a conditional join, like R conditional join with S, such that R dot A is greater than S dot B, and then we are retrieving phi of A. Okay, so it can be replaced with a conditional join as well. Okay, so these are the two methods in which we can find the retrieve the value of A which are greater than some values of V. So here it is, this expression is used when some or at least or any term is used. Okay, so it is used to retrieve records of R, those are satisfied given condition by at least one record of S. Now what does that mean, at least one record? So when we are comparing the value of A with B, then what we are doing, that if for any A value, if it is greater than any B value, then we will be retrieving that. It does not mean that if it is greater than one B value and it is less than another B value, we will exclude that. So even if it is greater than just one B value, we need to take it. Okay, so this will be more clearer if we talk about another statement that tends to retrieve a values a values of R, those are those are more than every B value of S. Those are more than every B values of S. So retrieve A values of R, those are more than every B value of S. So this we have to retrieve. Okay, so in this case, what we will do, we have to retrieve a value which is greater than every b value of s. So here we need to make comparison with every b value. Okay, it has not to be greater than just one value, it has to be greater than every b value. So if we are doing this cross product of r and s, then we will be getting some a value and some b value, right? Now a value has to be greater than all the b value of s. So here the trick is, we will be subtracting the a value from r. Okay, we will be subtracting the a value of r from the a which are less than either or any of the b value of s. So here we are taking r dot a less than s dot b. So we are subtracting all those a value which are less than any b value. If we are subtracting it from the total value of r, total value of a in r, then we will get those a value which is greater than every b value. Okay, so this is the equation, relational algebra equation for our uh, acquired statement. Okay, so in this way, see, this you can find out via writing some values, like you have this r and then you have this s, and give some value of a and b, and then you are doing, like, let's say 5, 10, 15, 20, 25, and let's say we have here 8, 3, 8, 5. Okay, 50, and then we have something called 60. Okay, let's say some random data. Now you will be doing this cross product, so you will be having 5, 3, 5, 8, and so on, like this. For every value it will be paired with every value. Now you have to compare the a value, has to be greater than every value. So if it is greater than this, if it is less than this is not included. Similarly, you have to compare like this. So in order to do that, what we will do, we will do that if this value is less than any of the value in b, we will not select this. Okay, if this value is less than any of the value of b, we will not select this. If this value is less than any of the b value, we will not select this. Okay, this way we will go. And if this value is less than any of the value of b, we will not select this. So 60 will not be included in this part. So if we are taking the entire r value and subtracting this whole part, what we will get, we will get this 60. So it's just as simple as that. So what we are doing, we are checking, we need to retrieve a value more than every b value of s. Okay, every b value of s, and this we need to find. For that, we have all value of s, all value of s, sorry, all value of r, all value of r minus a value, a value less than or equal to any b of s. So equal to is also necessary, because we are talking of mode. Okay, so here we can write it like this: phi a r equal to phi a r minus phi a, and here we are applying condition r dot a less than equal to s dot b for r cross s, or this can be further be written in the form of join. Okay, one more thing, here I forgot this part. Okay, so one more thing, it can also be written as phi a of r equal to phi a, projection of r, not phi, projection of a on r minus projection of a and natural conditional join of R and S with a condition that R dot A less than equal to S dot B. Okay, this way we can write it. So this is one more type. Now there is one more operator that we have, that is kind of basic operator only, and that is known as a rename operator, which is very much used in this kind of example. So a rename operator is used to rename table instance, uh, table instant, or it can also be used to rename attribute of the table. So used to rename rename the table instance, or rename the attribute of the table, rename the attribute of the table. So either it can be used to rename table or attribute of table. For example, if we write like if we have a table called student and we want to name it T1, so we can write it row T1 comma student. So it will be represented like T1 is the table, and all the fields will remain the same. So SID, SNAME, and age. So these will remain the same. Okay, so row T1 is a way to rename the student table as T1. Okay. Similarly, if we want to name the attribute of the rename the attribute of student, so we can write it as row I N A of student. So here we are renaming the attribute of a student table as I N A. So I map to SID, N map to S name, and A map to age. Okay. So this is the way of renaming the attribute. Otherwise, if we want to rename just one attribute, so we can write like row student, and let's say if we want to make the first attribute as I, and we want to make the third attribute as A, but we don't want to change the name, so it will be like student table will be there, and inside the table the first attribute is I, the second attribute will be name, and the third attribute will be age. Okay, this way. So this way we can rename a table. So it is a very easy process, but let's see why we need to rename a table, for what purpose we are doing this. Okay, so this we will see via some questions. So let's say if we need to retrieve a values of r that are more than some other a values, some other a values of r. Okay, so we need to retrieve some a value of r more than some other a values of r. So now we have to do the cross product on the same table. So in this way this row operator comes into picture. So you have to do r cross r. Now you can't write r cross r and make a comparison. So here what we will do, we will rename this table, or we can rename the attribute. So either we can rename the table, or let's say we rename the attribute of that, and we have to find r dot a, and we can do cross of r, and we can do row of r, and we can name a as or we can do rename the table as r1. Okay, so okay, not this way. So row r as r1. Okay, I did just opposite. So we are doing t1 and r. Okay, so we are renaming the r as t1, and here what we are selecting, that r dot a is greater than t1 dot a. Now this t1 is also r, but we have renamed it like this, and then we are taking the r dot a this way. So now a rename comes into picture. So either we can do this way, or we can rename both the table as well. Okay, so we can do something like phi. Okay, first let's rename this table. So row, um, I'm doing this and again. So we are doing like row t1 r1, sorry, t1 r cross product with row t2r, and here we are applying the condition, selection condition, t1 dot r is greater than t2 t1 dot a greater than t2 dot a. So we need to retrieve all those values from r which is greater than some values of same r, right? And now we have to retrieve, t1 dot a. Okay, so this is the way we can rename the table and retrieve the corresponding values for that. Okay, so yep, this is the way you can do this, and this is actually one way. Other way is like just we need to rename row t1 r and row t2 r, and then we are doing this t1 join t2, applying the predicate condition t1 dot a greater than t2 dot a, and then we are retrieving phi t1 dot a. Okay, so this is another case. We can rename the attribute as well. So particular attribute we can rename, so that we can do like r join with row r, and here we are renaming a to a1. Okay, so only one attribute is there, so let's make it a1, and here we are making that a has to be greater than a1, and then we are retrieving phi a. Okay, this way we can conclude. There is one more example in which we say that we need to find the SIDs. Okay, so we have a table of student. So we have the student table, and it consists of SID, name, and age, and we need to find SIDs of students whose age whose age more than age of some students. Okay, so we are making the comparison in this same table. So what we will do, we will rename this table to s1 and student, right? And then we can do this join with s student table, and we can compare like s1 student dot age greater than s1 dot age, and we are retrieving phi sid. So we can write student dot sid. Okay, so we are retrieving the sids of those student whose age is greater than the age of some other student. In other way, we can write it simply like if we are renaming the attribute, so student natural join row student, and we are renaming it as I, N, and A, and we are saying here that age greater than A, and here we are retrieving phi SID. So this SID correspond to this student. Okay, so yeah, this is the way we can find it. Let's see one more example of this. So if we are told that the same table, so like we have this student table, but we have attributes like SID, marks, and let's say gender. Okay, And here we are told that retrieve female student SIDs, female student SIDs who scored more marks than some of the male students. So now there are two comparisons happening. First, we need to check the gender, and then we need to check the marks corresponding to that gender. So here we are doing student natural join with row of student. Okay, and row here we are terming as I, M, and G. Okay, and here what comparisons we are making, that the gender of this student, okay, this gender is equal to female. And so for and we make use of this symbol like this. So if the gender of the student is female and marks, okay, let's make the gender of another part also. So first we are comparing the gender of first student, then we are doing comparing the gender of second student table, I mean this one. So we are making it as male. If so this gender is female, this gender is male, and one more condition we have to make, that marks greater than M. Okay, let's make it female, and this gender is male, and marks greater than M. So uh, for each entity we are comparing that, for each entity if the gender is female, and for the other entity in which it has cross product the gender is male, and marks of this particular entity is greater than marks of this entity, then here we are retrieving their SIDs. Okay, so this is the way we can check. Otherwise we can also do the rename of the table. So either way it is correct. So first we are renaming both the table as T1 student and row T2 student. Okay, and then we are trying to make a conditional join of T1 T2, and then we are checking that T1 dot gender is equal to female, and T2 dot gender equal to male, and the third thing that we are checking is T1 dot marks greater than T2 dot marks. Okay, and after that we are retrieving the projecting the SID T1 dot SID. So we are retrieving the SIDs of those students whose gender is female, and the from whom we are comparing whose gender is male and their marks is greater than the male marks, right? So this way you can write the equation, and you can also follow this via like writing cases. For that, make two student table and then make the separate comparison and then write the result, so that you can also go back to, and illustrate this way. The other example that but it was an easy example, so I'm just writing this way. uh, there is one other example. If we are asked to retrieve female student IDs, female student IDs, that is SID, who scored who scored more marks than marks of every male student, than marks of every male student. So in this way we will follow the earlier approach. So what we will do, we will take all the SIDs of those student from the student table where gender equal to female. So we will take the SIDs of from the student table where the gender is female, and then from here we will subtract those SIDs from the student table. Let's say it is T1 student. uh, just a second, let me write in a clear way. So we from here we are subtracting the SIDs from students natural join with conditional join with row T2 student, and here we are checking that T1 dot gender is female and T2 dot gender is male. T2 dot gender is male, and then we are saying that T1 dot marks is less than T2 dot marks. So we are subtracting the SIDs of those female student who scored marks less than some of the male student, and that we are subtracting from the entire SIDs of female students. So here we will get those female student SIDs who scored more marks than every male student. Okay. One more thing to note, I just forgot this part. So we have to write like this because we are comparing more. Okay. So this is one way of writing. So these are the some of the instances where we need to do write the relational algebra expression for some of these statements. Let's see one last statement. Like if there is a table of employee which consists of EID, e-name, then department number, and then salary. Okay, and then we are told that we need to retrieve EIDs, employee IDs, whose salary whose salary less than some employee salary of department 5. So we need to retrieve the EIDs whose salary is less than some employee salary of department 5. So here what we will do, we will first rename our table as E1 employee and another copy of employee table as E2, and then what we will do, E1 natural join with conditional join with E2 with a condition that E1 dot salary is less than E2 dot salary, and E2 dot department equal to 5. Okay, and then we will retrieve phi E1 dot EID. Okay, so we are retrieving the EIDs of those employees whose salary is less than some other employee's salary and some other employee has a department of 5. Okay, so this way we can illustrate this part. Another thing, if in the same question we are asked that retrieve retrieve EIDs whose salary less than every employee of department 5. So we need to retrieve the EIDs of those employees whose salary less than every employee of department 5. So what we will do, we will find the EIDs whose salary greater than or equal to any employee of department 5, and that we will be subtracting from the entire EIDs. The same approach like phi EIDs and EMP. So it will take all the EIDs of from the employees part, and then what we will do, we will subtract the EID of T1 conditional join with T2, with T1 dot salary greater than equal to T2 dot salary, and T2 dot department is equal to 5. Okay, so this way we can conclude this part. So yeah, these are some of the questions that we can go with. Next we are going to see the set operator, and after that we will come back on to the part where we decided upon deciding the number of tuples from each operations again. So yeah, this is all about this, and next we are going to learn about some of the set operation like union, intersection, and minus, and then we will go back and see the division operator, which is an important operator, right? So yep, this is for only, and if you do have any comments or question, please do post your comment in the comment section. Thank you very much.